Well, hey, everybody, thank you so much for coming out at 4 o'clock the Thursday afternoon. I hope you're all having a great conference and really appreciate you taking the time to join my session. My name's Todd Golding, and I'm a partner solutions architect at AWS. And I'm part of this team that's called the SaaS Factory team. And that team basically is involved with customers who are building SaaS solutions, and we're helping them with either design or development or rebuild of a solution in a SaaS model. And as part of that team, we build all kinds of content. In fact, I encourage you, if you're just generally interested in SaaS, to go look up the SaaS Factory, and you'll find all kinds of reference content related to best practices and approaches, both on the business and the technical side. And as part of that team, we generally, and even as part of content we deliver here, we'll often talk about competing approaches, different strategies, and try to give you some idea of patterns and practices that are good ideas for you. But what we also decided a while back was, I think it'd be really helpful to show people sort of an end-to-end working example. People are saying to us, that's great, we love all these sort of patterns and practices, they're all great things and they're good things for us to think about, but could you just show us an end-to-end working example of a SaaS application? And yes, we know that may not be exactly how we'll build our SaaS application, but with that example, it'll give us a much better idea of how some of the building blocks come together and what a real working sort of version of this looks like. And so last year, a member of my team and I, Judah Bernstein and I, we built what's called a quick start. And if you haven't used a quick start at AWS, that's just this downloadable construct. You can download it, install it, and so on. And in fact, there's a whole range of good quick starts out there for you to look at. But this particular quick start was focused on this very specific problem. How could we show you a working example of an application? And it's not meant to be a production application. It's just meant to be a reference point, a starting point. And everything we're going to talk about in this session today is based entirely on that working example. So our goal here is not to wander off into all the sort of parallel paths you might go and all the alternatives. Instead, we're going to pick a slice of a specific kind of SaaS application and walk you through that end to end. Now, a couple caveats. Some people come to these sessions and they're like brand new to SaaS and they haven't really sort of dove into the concepts. This is a 400 level session. I'm not going to teach SaaS fundamentals in here. That there are plenty of good content out there for this. This is a 400 level session, which means we're going to poke at some code and we're going to stay under the hood more. We're not going to crack open the IDE, and I'm not going to build SaaS from scratch in a few minutes, but we will poke at code. And so hopefully, based on the abstract and everything else you sort of read about this session, that absolutely fits for you. And then I will say at the end of all this, I'll give you the link to the content that's here so that you can go out and get a good look at this and absolutely take a look at what we've created and give us feedback on what kind of things you'd want to see. So enough about the sort of setup here. Let's actually dig in and look at this application and what it's all about. And before we can kind of wander into the code and the services that are part of this solution, I need to give you some sort of foundational view of what are the moving parts of this environment, what's in it, right? And obviously, we're building a multi-tenant solution. We're SaaS. We have to have tenants, multiple tenants in here. And we're building a very specific kind of multi-tenant solution. We're building what we call a pooled SaaS solution. And when we say pooled, what we're basically saying is the resources of our application, the infrastructure resources, compute and storage and so on, they're going to be shared by tenants. In this model. Now, there are other models of SaaS. For example, we talk about silo models where each tenant will either get their own storage or their own compute, and those environments are entirely valid as well, but not in the scope of what we're going to talk about today. But I absolutely want you to know there are other patterns out there, other strategies, and if you go look at our content, you'll see that. Now, the first piece we're going to look at is onboarding. And usually when I go talk to customers and partners and they want to talk to me about SaaS and I bring up onboarding, the typical response is, that's not something we need to think a whole lot about. We're more interested in our microservices and our storage and all these other bits. And I will say to them, I think onboarding is one of the most important pieces of building a SaaS solution. Getting onboarding right, how tenants get introduced into your environment, how you create a footprint for a SaaS tenant is essential to the rest of the architecture of your solution. how you resolve a user to a tenant, how that tenant has a billing life cycle, what provisioning you might have to do in configuration to set that all up. When we're done with this exercise, you will see how the work we did in onboarding set up the flow through all this in a way that made our developers more productive, made our isolation story a better isolation story, and so on. And I want this process to be really robust. I want your onboarding to be robust. I want it to be repeatable. You don't want tenants trying to onboard onto your system and having that be a somewhat flaky process. You can't have, well, it fails every other time and we just retry. And I know this doesn't matter whether you're B2C or enterprise or B2B. I want this process to be automated and robust. The next thing we're going to look at is authentication. And on the surface, you'd say, well, authentication, I already know that. I know how to connect to an identity provider and auth the user and get them into the system. But right here, in a SaaS environment, we're not just authing you as a user to get you into the system. We're not going to talk about how to do that. What I have to do is when I auth you here as a user and you come in, somehow when I auth you, I have to know which tenant you're connected to, because the context I need is not just you as a user. I need you as a user for a tenant. So when we auth you, we're going to look at how we auth you and how we get an identity profile that flows all of that additional SaaS context through our application. Finally, we'll look at the actual way that you build multi-tenant application services, right? And here's where everybody thinks, well, this is where the nuts and bolts of real good architecture and real good SaaS design are going to come in. No, not really. The truth is, in fact, if you write a really good multi-tenant solution and you build a really good isolation model, you really build a good identity model and all those other bits. Our goal really is to say building a multi-tenant application service shouldn't look all that different than building a single tenant multi-tenant service. So we're going to look instead at how we surround those services with frameworks or tools or libraries or mechanisms that will take all the multi-tenant context and hide it away from the services. Finally, we'll look at storage partitioning. And this is often where a lot of people, when they're looking at SaaS solutions, they think that's where it's at. In fact, what they'll do is they'll essentially take an environment, they'll make a database for every single tenant, and then everything else stays the same, and that'll be their multi-tenant environment. And here we're not going to dig a ton into storage partitioning strategies. There's white papers I have out there and blog posts and all kinds of other bits. Here we're just going to look at, in the context of this application, how did we partition the data it stores, and how did we resolve tenant context for that storage partitioning. And then the last piece of this application side of the house is one that most gets overlooked and is often highest on my radar, which is this notion of tenant isolation. If you think about selling a SaaS product, and you think about somebody coming to you and buying your product who's especially maybe in a space where they're very worried about their data, but today actually the truth is generally just individuals are very worried about how their data is protected, but also how their environment and their resources are protected. You have to have a scheme, you have to have an answer for those customers that says to them, what have you done to ensure that my data, my resources can't somehow be accessed by another tenant? Imagine having a SaaS business and having some tenant come back to you and say, hey, I'm seeing somebody else's data. I don't know what's going on, but I'm seeing their data. What kind of ripple effect is that going to have through your business? That's going to be huge. So we have to look at tenant isolation not just from the perspective of authentication. Yes, we want to authenticate people. We want to be sure we have a good security way to get in the front door. We want to look at how we can build layers of security in here, multi-tenant security, and we want to look at ways that we can apply policies and rules here to prohibit cross-tenant access. So if you came here thinking, identity and isolation would be outside of this story, they're just sort of tangential concepts. No, they're going to flow through this whole discussion because they're table stakes for a SaaS solution. Finally, we'll look at a couple other topics very lightly here. We'll talk about metrics because just fundamentally metrics are super important, metrics and analytics to SaaS environments. But unfortunately, just because of time constraints, we won't be able to dig into that area. But I just did a webinar on this. I've got other talks out there on this. Other members of my team have talks on metrics and analytics out there. We talk, in fact, about cost per tenant and things like that. Really important bits. We'll touch on billing lightly also. We won't even get into management monitoring, even though I think it's a super important topic. But that's the architecture we have, and that's the moving parts of it. Now, what is the stack? What are the language? What's the tools? If you were to go get this out of GitHub, what would it look like? What are you going to get? Well, the client of this is an AngularJS application hosted in an S3 bucket. Essentially what we try to do is push all the client over to the browser, host it from the edge, and obviously we're AngularJS, and we wrote this a year ago, and just like you would expect with UI frameworks, there's already better Angular, there's already React, and there's all kinds of other cool things we wish we probably would have used here that will be outdated by next year's reInvent probably. I don't know. It feels like the client libraries move a lot. But anyway, for better or worse, we're in AngularJS. And then we're going through the API gateway to get to our actual application services. And we'll look here at how we use this notion of a custom authorizer as one of the security layers of our application to control flow through that gateway and limit access to the data. And then finally, we'll get to the nuts and bolts of what the application services are themselves. And here you'll see these services. There's a few of them that are sort of domain services. This is a really cheesy, really lightweight order management system that does almost nothing because we really weren't worried about what the app did. We were more worried about the mechanisms here. So you'll see order management and product management, but then you'll see a handful of other services here that are more about orchestrating the onboarding, supporting the isolation, supporting the registration of users, and so on. And finally, I have to list Cognito here because a lot of this solution relies on Cognito. It's using Cognito for identity. It's using Cognito as part of our isolation story. Now, just because I have Cognito here, I wouldn't want you to think this would only be achieved with Cognito. There's plenty of other good identity providers that could be plugged in this equation and solve this problem for you. There are some nuances with identity and Cognito that give us some ways of applying isolation that are kind of clever because Cognito has awareness of IAM. So it's kind of helpful in that respect, but don't think that you need to use all these tools these ways. These concepts are still valid with or without the tools I've chosen here. The last bit, and I'll go through this quickly, is, well, yeah, but if I actually go install this thing and I go download it and I run the CloudFormation that sets it all up and I go look in the console, what kind of resources are going to get provision of that as part of that? Well, you can imagine we've built this using sort of the best practices, well-architected model for any quick start or any solution that's out there at AWS. We built for redundancy and high availability and so on here. So we've got a multi-AZ solution. We're running in a VPC. And then our client is out at the edge running an S3 coming through the API gateway with this custom authorizer I mentioned. And then we have public and private subnets. So at the public subnet, we just have a NAT gateway because we don't want our services in the public subnet. And then you'll see here we got load balanced access to our private subnet where our services are going to reside. And then we actually have our services, which are running in an ECS cluster. This is like you could take SaaS off the branding of this entirely and just say this is sort of a boilerplate approach to just a good ECS architecture. So anyway, that's the moving parts of it. Let's now get into the onboarding. And like I said, onboarding to me has lots more moving parts to it. It took a while to write the onboarding bits of this. And I'm going to do two phases to looking at onboarding. I'm going to look at the surface of onboarding, even though it's not very technical, and just go with me for a minute because this isn't about the UI, but I'm going to show you the surface, and then we'll talk about why that surface is important, and then we'll dig underneath it a little bit. But if you look at the onboarding of this application, it's just a very simple collect my data, tell me what tier I'm signing up for, because usually when you sign up for a SaaS solution, you provide a tier. And then once I sign up and push register, I'll get a message saying, hooray, you did it. I'll get an email sent to me that tells me you've signed up, validate who you are, here's some temporary credentials. I'll log in with my temporary credentials. The system will detect that, hey, you have a temporary password. It'll challenge me to change my password. A flow you've probably seen, probably much more elegant than this, but generally seen in a whole bunch of applications. So why did I show you this? Well, the point of all showing you this is that almost all the moving parts of this, if you were to open up the quick start and look under the hood of the quick start and look at the implementation of this, you'd find that almost none of our code is orchestrating this process. Cognito is doing almost all the heavy lifting here. The email that gets sent, the template of the email that gets sent, the generation of the temporary password, the challenge when I log in to recognize that I've got a temporary password and the reset of this. The password policy, that is the policy that says what characters are accepted and how long does it need to be. Those are all part of Cognito. And so my point here is, whichever solution you build on your own, if you're orchestrating all of this on your own and implementing all these policies on your own, you shouldn't be. You should be relying on somebody else to do that, because guess what? This space is changing all the time. All kinds of new identity mechanisms are coming along. Even within Cognito, I can say, do you want multi-factor authentication? What's password expiration policies? All these other goodness, and it's all not part of my code. So the only reason I showed you that was that. Now, let's look underneath the hood of it. So now these are the services that we're orchestrating underneath it, the microservices that are part of the solution. And so when you push that register button on this application and you hit the registration service, it will then orchestrate the creation of all the moving parts. And the first thing it does is go to the user management service and say, I need to create the identity for the user that just signed up. So it will go out to Cognito. And in this case, we're using Cognito, by the way, in an OpenID Connect model. So there are many people who implement OpenID Connect. It's an open standard, and we very much rely on that model for our solution. And then within OpenID Connect, we configure some very important moving parts here. The first one and the most controversial one is probably this user pool. When we first built this, we said, in fact, it's still this way today, we said it would be really nice to have one user pool for each tenant in our system. And we thought that was a really good idea, because we thought when we want to go configure all these options that are available, passwords, MFA, all these things I just talked about, they're configured at the user pool level. And so this gives us a way to pass that ability along to the tenant and let the tenant decide, what do you want your password policy to be? What do you want your MFA policy to be? And each tenant could have their own sort of rules for that. That didn't turn out to be a great decision, and I'll talk about why in a minute. I shouldn't say it's a bad decision as much as it comes with some constraints that you'll want to be aware of. Also, we have to provision an identity pool. This is just a moving part of Cognito, which is our federated identity. And then we actually have to create this very first user, who is the user in our system, the admin user. And then the last bit is the most important piece you should note on this slide, is these custom claims. So OpenID Connect has this notion of a set of attributes that are claims that are the standard claims that are part of the specification: name and email address, phone numbers, things you would expect. But it also says, hey, if you want to introduce any of your own custom attributes, you can add your own claims to the identity profile, and those claims will follow you as a user through the system. Well, you can imagine what that represented to us when we looked at it. We said, well, we have these users, we've got these users in the system, but we want to bind these users to tenants, and we want to know about the tenant's tier and their status and all these other things as we look at individual users. If we bind them to the user here through these custom claims, they'll just follow us through the whole process. So we introduce those custom claims, we configure them, we configure tier and status and tenant ID and so on as part of custom claims. Then we go over to IAM. And in IAM, we go over and configure some policies. I'm not going to dig into these policies here right now, but essentially for every role for the tenant, we provision a set of policies, and these policies are going to be used as part of our tenant isolation story. I'll circle back to how they come into play near the end of the talk. Finally, at the user management service, you'll see that I map the user to the user pool, and that may not be so obvious from the diagram, but this is what I'm talking about, user to user pool. And here's one of the points of having a tenant per user pool that's a problem with this implementation. I'm going to have to authenticate at some point, and when I have to authenticate against the user pool. But when the user comes in, I don't know what user pool they're part of. So I have to introduce this user management service that has one role, is to map the user to the user pool so I know what to auth against. Now, that means that that doesn't mean data about the user lives in user management. It still lives in the identity provider, and it should stay in the identity provider. Instead, we just have this mapping here. Finally, we actually have to create the tenant. We still didn't have a tenant yet, so we have to go out and put the footprint of a tenant here. What's their ID, what plan, what's their status, what are all the attributes and policies you might have about your tenant. And there's an important takeaway here, which is when we first provision this, the user we provision here will have a one-to-one relationship with the tenant. However, over the life cycle of this tenant, we will add users and so on, and there'll actually be a one-to-many relationship between tenants and users. Now, just to show you, we talked about these custom claims. If you were to crack open the console and look inside of Cognito after you provision a new tenant, you'd see these custom attributes got populated. So here you'll see tenant ID, tier, company name, and so on. These are those custom attributes that are so fundamental to what we're doing. The last piece of this provisioning is the billing piece of it. Now, a lot of people don't factor billing into their onboarding, but the truth is, if I'm setting up a brand new user, I've got to be charging that user somehow, and in most systems, that charging is done based on some formula of consumption or number of users or something. So I have to go set that account up in some kind of system, typically a third-party system, hopefully, but if it's not, even if it's your own external system, you still have to, your own internal system, you still have to go provision that account. So what I want to say here is, hey, this account eventually has to exist, but I don't want my registration process to count on the creation of that account right now. If for some reason the billing system isn't up or it doesn't succeed at creating it, I don't want the whole registration process to fail. So what I do here is I just send to a queue, hey, go create the tenant. I want it created. I'm done. Go ahead, registration. You're done. You succeeded. Go let the tenant know that they can log in right now. And then in the background, I'll have another service that will actually pull the message out of the queue, talk to the billing system and say, hey, I'm going to try to create the account in the billing system here. And if it fails for some reason, I'll have some kind of fallback strategy. Here we'll keep retrying till it gets created. But conceptually here, make sure you realize that somewhere out there in this billing system is the notion of your account for this customer. And over the life cycle of this, there's going to be a point at which somebody's going to go in who manages that account and says, I may need to update something about this tenant. They move from basic tier to premium tier, or they're not paying their bill, and so they're going from, their status is going to go to on hold or something of that nature. So I also have to have an integration. It's not here and it's not in the example, but I want you to realize there's also an integration that has to come back and update the tenant status in that tenant management system from your account management. Okay, everything's here. And just one more caveat. Often another big piece of this onboarding that isn't here is the provisioning of actual infrastructure. If you're in a siloed environment and each tenant has their own infrastructure, that would mean our onboarding would also have to include provisioning and configuration here that would go out and actually create whatever infrastructure is needed. Okay, tenants in, tenants created, the whole identity profile's created. Now let's get a user into the actual system. Let's auth them. So now the app comes in, the tenant comes in, they hit our web app, and in a normal authentication flow, the web app would typically go right here and redirect to the identity provider and say, go auth them. But we have a challenge here. We can't go straight to the identity provider because we don't know which user pool to authenticate you against. So this is caveat number 2 related to having a tenant per user pool. I need to go get which user pool. So we have an auth manager service. Well, now my auth manager service is a point of failure in my identity process, something I have to absorb and think about for scale here. Enough caveats on that. I'm just going to add real quick as a tangent. So when you look at user pools and you're thinking about whether you should have user pool per tenant, think about how many tenants you're going to have in your system. If you tell me you're only going to ever have 100 tenants in your system, use user pool because all the things that are good about it are still good about it. If you tell me you're going to have 10,000 users in your system, you might not be able to use user pool per tenant. That may not be a good fit for you. Now, we go to the auth manager. The auth manager goes to that user manager we had before. It looks in there to say, I need to find the user pool for this particular user ID and does the mapping. Goes out to Amazon Cognito and says, find me that user pool, because that's the pool I need to auth against. And it returns that back to the auth manager. Now, if the user didn't have a mapping to user pool or it didn't find it in Cognito, we'd fail the authentication. But in the scenario where it succeeds, we go out and auth against Cognito. Now, most of this is pretty straightforward, and it's already probably obvious. But this token that comes back from the auth experience, and I show ID token. The truth is there's ID token, there's an access token, there's actually I think there's 3 tokens from that. Oh, somebody help me, there's a third one. Refresh, thank you very much. I lost it there for a minute. There's 3 tokens, and in fact, OpenID Connect defines a very specific way these tokens are supposed to be used, ID token versus access token. I'm not gonna dig into all that, but know that the goodness of these ID tokens now have these custom claims that we defined embedded them. So not only do I have the user identity in here, I also have the tenant identity in here as well. And that is now gonna be key to when we write our application services. So, speaking of application services, we now have the context. We're authenticated, and we want to flow into one of those application services. And now we're going to go get products out of a DynamoDB database for our product management service. And so we're going to take an HTTP request in, and that HTTP request is going to be just like any other HTTP request on our service. But in the header of this HTTP request is going to be a bearer token. And that token, of course, is the JOT token that I just spoke about a second ago, the JWT token. Now, the product management service shouldn't care about the fact that there's a bearer token there. I don't want the service manipulating that token, opening it up, doing any kind of work with that. Like I said at the beginning, I want these services to not have to know a lot about multi-tenancy. So what I'm going to do is I'm going to introduce some helpers here. And by the way, I'm going to add caveats here that I think there's a better helper scheme than what we actually implemented, but I want to show you what we actually implemented. We created this little node module, just a little helper, and we said everything about token management, everything about the manipulation of tokens is going to be buried over there so that the product management service doesn't have to know about it. And so when the product management service says, I need a tenant ID because I want to do something with the tenant, it just says get tenant ID. It hands the request into the token manager and says, I don't even know what's in there, but somehow I know it's in there somewhere. Go crack it open, token manager, decode it, and send me back the tenant ID. Okay, now I have the tenant ID, and I'm about to call storage. And you could say right now, I have everything I need. Because the truth is, I could take that tenant ID, I could formulate a call to the SDK in DynamoDB, and that would return to me the appropriate items from the database. But I really worry about when somebody goes to access data, whether or not they're accessing in the context of the tenant that they're currently handling. This is all the way back to that isolation story. When somebody goes to get to data, I want to be able to say to them, you can only get to the items in that database that are valid for you, tenant. And if somebody in that code tries to cross that boundary, I'm going to stop them. So what I'm going to do now is a secondary step, which is I'm going to go out to my token manager and say, go get me credentials. Passing that same request in, it'll crack the token open, and it'll give me back a set of credentials. Now, we're going to dig into that process and what happens under the hood of that in code in a minute. But for a moment, just trust me, when it comes back, it gets a set of scoped credentials, and it uses those credentials as the credentials with the SDK to go access and get those items out of the database, with the assumption that those credentials are scoped in a way that I will not be able to cross a tenant boundary. Now, you could argue that's a whole lot of extra work. I could have just used a global set of credentials there. My code would have been simpler. There's not all this IAM bits involved. And I would say to you, this is back to the isolation story I was sort of harping on at the beginning of this. This is essential to protecting your data and preventing cross-tenant access. And do you have to implement it this way? No, but you ought to be thinking about some way to do this. So that gets me the protection I need now. We implemented this as a token manager, and it's awesome, but to me, the truth is this product management service should have never known anything about tenant ID. It shouldn't even know anything about get credentials. It should have just called the data access layer and said, get me some products. Data access layer should have did all these calls under the hood of the data access layer and just got me the rows and returned them. That would have been the better implementation. That would be a great way to evolve this. We haven't done it yet, so I want to show you at least what you get when you download it. Now, step one of getting these credentials is to just look at what it means to pull the token out. And this is Node.js code here, but if you follow the pseudocode, it's pretty straightforward. If you look at the top, here's get credentials from token, and it takes our request in. And then on the second parameter, you'll see it has update credentials. And in Node.js, they just use callback functions to return a result all the time. So update credentials is actually a function pointer. We're going to call that function pointer when we're done and use it to pass the result back to the caller. So then inside the function, well, not if I go forward, it won't push the right button. I'm going to break open the bearer token. If it's a good bearer token, I'm going to parse it out, decode it, and then I'm going to do some magic steps here that we're going to look at later, which is actually going to go get me these scoped credentials. And then the last step, this function at the end, assuming I come back with the results that are successful, I'm going to call update credentials, that callback function, and return back the credentials. Now, that gets me, that's the details of sort of cracking open the token, but we really haven't showed you yet still how that token gets mapped to the policies. We're going to get there. Now, so far, the layer of security I talked about was all the way down in the service. We used these credentials, and we said, hey, this service can't cross a boundary now when it tries to get data. But we can also protect our environment and protect our data and protect our resources at the API gateway level of our solution as well. And like I said, I want security at every level. Just because I have it down in the service doesn't mean I'm not going to wander up the tiers of the architecture and say, where else can I prevent somebody from getting through? And so here at the API gateway, we have this same old token coming in that is an awesome token with all the goodness we talked about. And now we can put this Lambda function out there called a custom authorizer. And this custom authorizer will let us crack open that token, see who you are as a tenant, see what role you're in, and decide which paths through the API gateway are allowed for you, so that I only open up the paths to services that you're allowed to touch. Now, if we crack that open, and we look inside that, and this is a much more simplified version of the code pared down from what you'll actually see. But the concepts are here. Essentially, I'll go out, I'll get the JOT token out of the request, you'll see here. Then I'll construct this auth policy. You'll see the auth policy. This is just an API gateway construct here that is the policy that's going to tell me which paths are allowed through the API gateway. And then the part you really want to pay attention to is this if statement. In this if statement, I'll look in the token and say, are you an admin? Oh, you're an admin? Then I'll configure this policy object to say every path through the API gateway is allowed. If you're not an admin, I'm going to constrain this to only allow a get on all the functions, and I'm going to allow you one post to create users. Now, obviously, the final version of this looks more elaborate than this, but you can see how this policies control paths through the API gateway, and you can see how looking at that token would let me say, hey, you're an admin role. There's like 4 or 5 roles in the system. Based on each one of those roles, I will open up the paths through to varying degrees. Okay, so we looked at app services. We looked at how our app service got the token, used it to get to data. Well, what did we really do to represent data in our system? And we used a pretty straightforward model because we really didn't want to go way down the sort of the rat hole of all the different things you need to think about partitioning. So here we basically said, let's use DynamoDB to store our products. And in this case, we're going to store our products, and we're going to use the partition key. This is a pooled model for storage. So instead of having separate databases or separate tables, here we're using a shared table for all tenants. And in the partition key, sorry about that, pointing the wrong place. In the partition key, I will put the tenant ID. So you'll see that in the left-hand side of that table. And that will be my way of determining which data belongs to which tenants. And then what we've done here is we've said, let's put something between the service and the actual access to the data so that the service itself doesn't know anything about the partitioning scheme. So when we go through DynamoDB helper here, this helper class, it's the helper's job to say, is it a key? Is it a table? Which table? How do I figure out how to do all that? Make that all DynamoDB's responsibility, and then let all that happen on the other side of the line. And to me, that's an important point because I never want my application services going, well, what's the connection string? Oh, this is 2 separate tables for each tenant, so here's how I'll resolve it to a connection string. And then that ends up in the service, and it ends up propagated across all the services in the system. Instead, I want the partitioning scheme on the other side of some helper. And then just for an example here, I also want to make it clear that you could have other kinds of storage on the other side of the service. So I said, what if we added product images? They're not in the current solution you'll get, but if we added product images to our product catalog, we'd add an Amazon S3 helper, and in this case, we have a different partitioning scheme. We'd use tags on S3 objects to say which objects in the S3 buckets belong to which tenants. From the consumer of the product management's perspective, this is all just a REST interface, and I don't care about how the data is represented. Now, this is going to look like a really simple function, and it is, but there's an important caveat in this function. This is the function that actually goes out and gets the data from DynamoDB. And if you look at this function, this is the downstream. We've got the credentials. We've got those scope credentials that we talked about earlier. Those credentials come into here as a parameter on that function that you see there. And then we configure the search parameters for our DynamoDB SDK call. So you'll see here, I put the table name in, and then I put the tenant ID, which was acquired in a scope outside of here, into this expression. I construct this DynamoDB helper object, and I call query on it to go get the products. Really basic, really straightforward. But one nuance in here that was really challenging for us, at least, was that you'll notice here I passed the credentials to the DynamoDB helper when I construct it. When we looked at other sort of wrappers of DynamoDB and other tools, because we really didn't want to write a helper ourselves, we found that most of those tools had a global configuration of the module that once it got the creds, those were the creds for the life of that instance. Well, in our case here, those credentials change every single call potentially. And so we needed the DynamoDB interactions to apply brand new credentials every time, and the only way we could find to do it was to create our own wrapper around DynamoDB SDK to do it. Now, my guess is since we created this, or just because we couldn't figure it out, there's some library out that does this, and by all means, if you find one, A, let me know, and B, use it instead of this approach. Okay, so we've talked about credentials and getting this data and identity and all these things and the storage, and it sort of looks like I've isolated the data with those credentials. But the truth is, right now with the implementation, as I've showed it to you, I really haven't done anything that connects the ID, the ID of the user, the identity of the user, to these IAM policies that were created. So right now, when tenant 8 comes in and they evoke this function to go get the items out of the database, yes, they're going to go get credentials. But the truth is, they could plug any tenant ID they want into that request. So instead of tenant 8, they could put tenant 1 into that request and go get items for tenant 1, because there's nothing that connects the identity to the policies that enforce that access. So that's the missing piece I need to plug in for you, and it's probably of the pieces, to me at least, the most confusing one. So hopefully I'll straighten that out for you. So part one of solving this problem of connecting the policies to the identity is we need to look at what's actually in the policies. So if you remember at the very beginning, I said we're provisioning these IAM policies, and I'll tell you what they're all about. Here's an example. We have these roles, and I have one example of one role here. And what you want to look at is at the very bottom of this policy where you see the conditions section. You'll see it down here. And in this condition section, we have specifically this idea of a leading key. And what the leading key says is essentially this value must be the leading value in the partition key, or you can't access the data. In this case, it's a tenant ID. So if you don't have this tenant ID, you can't see. That's the only data you can see. So that gives us a way to describe the policy, but we still haven't attached it to the identity. And the way we attach it to the identity, to me, is kind of clever. In fact, I was in the code when we built this, and I was working with Judah Bernstein and our team on this, and I'm looking for it, and I'm trying to figure out, how did that policy get attached to the user? It's working, but I don't see any code that ever connects it to it. And it's because Cognito is doing much of the work for us here. So you remember at the beginning, we created this user pool, and we configured these custom claims. And we put tenant ID and role and these other bits in here. But we also had to create this federated identity that we got back. And what you didn't see, because we didn't talk about it, was as part of creating that federated identity, we also created these auth role matching rules that you see on the right-hand side. And these role matching rules, in fact, if you go in the Cognito console and open it up and look at a federated identity provider, you'll actually see a place you can configure these role matching rules. And the whole point of these role matching rules is to say, hey, if you ask me for a token back for a given role of a user, I can match it to a policy, and that token will come back with the policy attached to it. And so what we did is, when we went out and created all the roles for our tenants, we configured this federated identity with the mapping rules to map each of our roles to the specific policies. So here's an example of what was under the hood of that. When you look in the application, you'll see these are basically expressions. And these expressions basically are role matching rules that say, hey, if role equals some specific value, in this case role system, then connect it to this policy. If role equals role support only, then map it to this policy. Those are the role mapping rules, and after you're done, in fact, if you saw after you provision a user in this environment, if you went and cracked open the console, you'd see that these role matching rules would have been created. Now, where does this happen in the code? Where do I actually do this? Well, if you remember at the beginning, I said, we're going to ignore part of that get credentials part that was another couple of function calls in there. Well, this is the sub part of that function that actually goes and gets the credentials based on that role. So here, if we look at this function here, you'll see that it essentially, we give it the identity pool. That's that federated identity pool ID. We just have to have that. We have it as part of your identity. And then we put the token in there. We didn't give it a role. We didn't give it anything else. We just have whatever the token is from your identity. And now we make this Cognito call. This is a Cognito API call here. Cognito identity, get credentials for identity. And that takes this param struct that we populated. Now, when I call that function, that basically goes over to Cognito. It applies those role matching rules, looks for the role in your token. It cracks open that token and finds it, and then attaches the policy to that and gives you credentials back that are scoped by that policy. To me, that's the secret sauce moment of this. And just to hammer this home one more bit, just with a little bit of animation, and we'll be done with this part of it. So if you look at this end to end, I hit my app service. My app server says, I want to go get data. OK, go to Cognito, say get credentials for identity, given the token for the user. Cognito matches the role. You can see, by the way, at the top, this is the token with a couple of the elements, one of which is our role. I match the role. I say, oh, this is the policy for the role. I create you a token, and I hand you back the credentials. And then at the bottom, you'll see I have a secret key and an access key. And that's the secret key and access key I'm going to go to use to access the data. Now, I can't cross the boundary. And in fact, in a lab we do here, we have a workshop ran Monday, runs again Friday. You'll actually see this in action if you go do that workshop, where you'll see, hey, you see where you could poke in the code and accidentally cross a boundary until this policy gets successfully applied. Now, you could argue that's an awful lot of work to get there, but I would say most of it's pretty seamless, and the value is pretty easy to argue. Yes, developers are going to try to do the right thing inherently, but that doesn't mean we don't have to protect them from mistakes they may not intentionally introduce. The last bit we're going to look at, and we'll go through this very fast, is what is the multi-tenant view on the client? And it's always hard to talk about the client side of this because client frameworks are all over the place, and the way people implement clients vary wildly. But what we did here is we wanted to say, we're going to build one single-page application for all the views of our application. So we have an admin, system admin, which is the ISV that owns all the tenants on the system. We're going to build a console for them, and then we're going to have a tenant admin console for that one tenant so they can configure their environment. And then we'll actually have this notion of a tenant user, which is just somebody using our application, and show how the application, based on your role, would show different views or enable different views. So you see here, system admin can view all the tenants. They can see system health. They can manage system users, so on. Tenant admin is more about how can I set up tenant users within my tenant and so on. Now, we're going to go past this real quick because this is AngularJS and nobody wants to look at it real close. But I want to highlight a couple of points in here. In the AngularJS, this root scope is just a global scope. You'll look at, we'll get, after we auth, this bearer token back. So you'll see in the response, I have this data.token on the second line here. That will come back and get put in my bearer token. Now I'll decode that token. You'll see. And now when I have the decoded token, I have all that goodness that I'm also passing to the service available on the client. So I'll display your name. Hi, Todd. Welcome to the system. And I'll also, more importantly, extract your role from that token. Now I can use that role to decide which views are enabled or disabled. Then I'm going to go create this little, I created this little helper function that is this isLink enabled function. And the whole goal of this function is essentially to take a view location, which is a portion of the app somebody wants to try to access, a path. It takes that as a parameter, and then it evaluates that view location to see which path in the application you're trying to get to. Are you trying to get to login? Are you trying to get to tenants? Are you trying to get to products? Which pages of the app you're trying to get to? And this isLink enabled will essentially turn enabled true or false based on whether or not your role is allowed to see that page. So you'll see like here is system user. That goes out and looks at your role. Is admin user. Goes out and looks at your role and determines whether or not you can see that page. And then the last bit here is the actual HTML of this. And the HTML calls that isLink enabled from the previous page and says, hey, I'm trying to enable the access to this particular link. Is it presentable? If it is or isn't, I will then turn on or off that link based on their action. Don't really care about any of the HTML or the Angular bits of that. What I really care is that you're saying, I want you to realize those roles and those tokens and that identity flow back to the client and need to be applied on the client as well. And having all those bits about your tenant embedded inside that token when it gets back to the client is valuable on that side of the equation as well. But if I broke it apart and really said, what are the things I really want you to do? I really just want you to extract the role from the token, go do something to provide some helper that say, what are the policies for what's enabled and disabled, and then in the HTML, turn on and off the views as you need them. An important note here is the note at the bottom of this page. Whatever I'm doing on the client to turn views on or off isn't part of my security story. Yes, I'm turning those things on and off because I don't want users to see certain things. But the truth is, even if the user got a view they weren't supposed to get, if they try to go to the server, I would hope my custom authorizer would stop them from getting from something they're not supposed to. And if they get past the custom authorizer, I would hope that my access policies in the services themselves would at least keep them from getting data they're supposed to. It's all about layers here. Now, I mentioned that I highlight metrics. I don't think this is the most complete implementation of metrics, and like I said, we don't have enough time to dig into this, but I at least wanted to connect metrics to this billing story because we talked about billing as well. But it's really important for me to tell everybody who's building SaaS, metering and metrics, these serve very different purposes to me. Absolutely, I want to meter consumption environment, then that might drive a billing story. But completely separate from that is the desire to just generally have metrics about activity and health and data that I can mine to tell me how is my system running, how are tenants using my system, when does it go healthy, when does it go unhealthy, and how can I do that with the granularity of a tenant. So if I want to be able to come back and say which parts of the system are being used just by this one tenant, I ought to be able to filter down to that tenant. If a tenant comes to me and says, I'm having a bad experience and the whole dashboard looks green in my management monitoring experience, I still want to drill in and be able to say, filter by tenant. Oh, I see tenant 3 is actually, even though everybody else is green, there's some yellow bits here for tenant 3 that look like they're having bottleneck problems here. So the whole point here is when I instrument the metrics, I want to put in really good metrics and detail about all the activity in my system, and then I want to embed the tenant context in those metrics events. And so, of course, I'm going to do this just the way any good architect or designer would. I'm going to introduce some kind of frameworky library tool between me and the metric system. Here it's shown as metering. So yet my tenants come in, they hit the API gateway, they hit my services. I show this metering config here just because you may have different configs for different services and different tenants. But the most important thing are these purple boxes here, which are metering. And my point is in the service, because I'm sticking consistent to my theme, I don't want my services to know a lot about how to successfully meter. I just want them to say, somebody wants this metric, publish the metric, and let the metering library say, oh, I'll figure out the tenant context, I'll figure out the bits about how these standard metrics need to get published, and I'll publish it with that context for you. And then I send it out to Firehose here, and then eventually into Redshift. And these are just examples of aggregation technologies. They're really good ones. But I would say to you, if you want to use Elasticsearch and Kibana or whatever you want to use here, there's tons of good aggregation technologies. I happen to pick these two because I happen to have built a sample with them. But another key takeaway here is all your metrics should land in this data warehouse, and then you should let consumers of those metrics decide what data is interesting for them to surface on their dashboards. I will often see product managers who want a very different view of what's going on than an architect and an operations person who wants a very different view of that data. I even see business sometimes wanting a higher level view of just generally, how many tenants have we onboarded? How long does it take a tenant to go from onboarded to successfully using the system? There's all kinds of bits here, and what I want to say is I don't want to constrain that in any way. Put all the data as a developer in here, encourage everybody to publish really good metrics, and then let everybody consume it. But in this particular case, I've talked about billing, and certainly one of the consumers of that data will be billing. Billing will pull the data out of Redshift. It will find the billable unit that's relevant to my billing system, and it will publish it to my billing system so that data can get there. And the last piece, I always hesitate to even include this slide, but because we built this and we thought it was fun when we built it, I throw this little slide at the end, which is we did create a little bit of a dashboard in here, and we mostly created this dashboard because we wanted to show the differences between what might be a system user's view of the universe versus, say, a tenant admin's view of the use versus a tenant user. So we wanted to toggle some UIs on and off. So you'll see at the top here we have this notion of service health. And all service health is meant to be here is you have all these microservices. They're green if the service is healthy. So when you're working with the app and for some reason a service goes down, you could give some notion of this. The idea, though, was to plant the seed that you could build more interesting dashboards that were custom to your domain here for a system view, separate from all the great management and monitoring tools you might be using. And then the bottom part were metrics, and those metrics are for tenant admins as well. So if you log in as a system, you get this whole page. If you log as a tenant admin, you won't get the system health parts at the top. Finally, takeaways. Well, I hope after this whole discussion that identity doesn't now feel like it's this tangential topic, that yes, we have to solve identity, but in actuality, tenant identity and the whole concept of how you represent identity affects the entire experience in your SaaS architecture. You saw through onboarding and how we created it, how we flowed it through an auth, how it arrived at services, and how it was used to connect to policies. And if you do that well, it's not so hard. If you don't do it well and you start sort of doing all these one-off bits to try to get it to work, it can get complicated really fast. So don't underestimate the importance of investing in identity. I think here that IAM, we talked about, and the way it can control access to resources, and then we can use it as part of our isolation story here, is a super powerful construct. I will also add the caveat here that IAM also has limits on the number of policies you can introduce, and there are issues here. So as you look at this solution and you're trying to decide, can I use this model in my solution, you need to ask yourself, how many roles will I really have? Remember here, we had roles per tenant. We did not have policies per user. We had policies per role. So that kept the policies from exploding. But you might still say, well, given all our roles and the way that we have to describe policies, we may run up against the limits of IAM. And don't look at the soft limits. There are hard limits out there. So you'll obviously potentially run up against soft limits, but the hard limits are much further out. So look at that. Generally, and I beat this one to death, but I think it's worth reminding you, in my app services, I don't want developers thinking about tenant context. I don't want them sort of improvising security and isolation for me. I want all those bits out of their view, and I want to write really good code to surround it so that I don't have to deal with that. This is a lighter point, and we didn't hit this really hard, but I've talked about this notion of a system user, which is potentially all of you as the user who are managing all of your tenants. When you go to build your identity story, this user often gets left out of the equation. So then you come back and you introduce some super user that has a special key or something that has a path through a bastion host to get into the system. I would prefer that you think of system users while you think about tenant users, so that you can potentially leverage. In fact, I have whole talks on identity where I talk about this. I would like you to leverage the same mechanisms that you're using for tenant users, policies and tokens and all those other bits, for system users. Now, they may get provisioned through a different process, but the way they get applied in the code, the way they realize isolation, they can leverage common mechanisms. And then metering and analytics, hopefully it's clear that that should be an early priority. To me, if I'm building a SaaS system from scratch tomorrow, I don't want to wait to get this data. In fact, as I'm making decisions about how data is partitioned and how my services are going to scale and how parts of the system I'm expecting to work really well will work, I want the data to back that up right away. I want QA and my automated testing to be pushing these bits and looking at these metrics and telling me, is my system doing what I expect? And the last one is, and this may already be obvious to some of you who may already work this way, but don't sort of go after multi-tenant in a siloed model where you attack one part of the system and then you eventually, after you build that all out, you eventually attack the next part of the system. I would prefer you say, let's get this little piece of onboarding working. Let's get this little piece of auth working. Let's flow that through to an auth service, and we'll write this cheesy little helper that only does a little bit of what it's supposed to do right now, and see that work all the way end to end, and then iterate on that before, and then learn from that and evolve all of those moving parts. I feel like you'll learn more in that path. So I promised links at the end. These are the links to the quick start. If you want to just go to the GitHub repository where this all lives, there's a nice big huge document that should resonate with all the things I've talked about here. And then if you just want general AWS content from the SaaS Factory team, the last link will get you to that. Webinars are out there and so on. We have not evolved this quick start a lot since we introduced it. We're looking at whether or not we're going to push real hard on adding functionality to that or build standalone versions of billing and monitoring some of these other bits. But would love your feedback on how you think it would evolve and how we could evolve it in a way that would be better for you. Finally, let's see if there's any days left here that would be relevant. We have a whole bunch, there's like 18, just on my team, there's like 18 sessions related to SaaS. There are chalk talks still remaining tomorrow looks like here on multi-tenant migrating and on optimizing. There's also the workshop tomorrow that I talked about that if you're interested and you've still got the energy that you could give a try. So that's it. That's the SaaS application. We pulled it apart. Hope you enjoyed it. Hope it was valuable to you. And I really appreciate you being here and enjoy what's left of the show.